Hello teachers and friends, today I would like to show you some of the applications of the Bernoulli principle in daily life. Okay, first, what if I blow on the top of this paper? What will happen? Okay, you can see the paper moves forward, and what if I blow between two papers? Okay. So it gets close to each other. So that is an you can see the application of the Bernoulli principle in that. Okay. Another one is this ping pong ball. Okay. I'm gonna bet you who managed to push to blow this ping pong ball out of this filter funnel. I'll give like $1 million. Okay. Okay, scientifically it's impossible because the low pressure occurred over here and between at the side of the ball will make the high pressure of the atmosphere push it towards the funnel, so it's never going to come out. What if I dig downside? Okay, it's the same. It will still stick with the funnel. Okay. Next is the Bunsen burner. Okay. Okay. First, light it up. So when we open it, the fire is blue, and when we close it, the fire is orange. Why? Okay. When we close it, there's no air, so when we open, the flow of the gas creates a high speed, so there's a low pressure inside, so the air from outside will enter the combustion tube, so a perfect combustion will occur. Okay. Next is the spray. Okay, when we push the tube, a high speed will happen. So a low pressure will be created over here. So high pressure will push the liquid inside. It doesn't matter if it's a poisonous one or something. It will enter the tube and it will be pushed by the force. Okay. This is the picture of it. So yeah, as I said, a low pressure will be created over here. So the high pressure will push the water inside this tube, and it will be pushed outside. Okay. Next is straw and the ping pong. Okay. This also relates with the Bernoulli principle. Okay, so this is one, and then what if I use a vacuum for this ball? Okay, you see? Okay, that also applies the Bernoulli principle. Okay. Next one is the carburetor. So I have two of them. This is the first one, small one, maybe for a small machine, and this is a car carburetor. Okay. So there's a big tube over here that flows the air, and you can see there's just a narrow tube. Narrower than the one before. So when the air enters the narrow one, the narrow tube, so a low pressure will occur, and then the fuel from the tank will enter the tube, and then it will move to the combustion tank. Okay. Next is an F1 racing car. So this spoiler is designed upside down of an aerofoil shape. So it doesn't fly or something at high speed and make it sticks to the ground. Okay, this is a diagram of it. So this is low pressure and this is high pressure. So the high pressure will move to the low pressure, so it will fly. So in case if the F1 car, so it will make it stick to the ground. Okay. So next is the airplane. Okay. So as I explained before, at a low pressure will be created over here on the top, and the high pressure will be created beneath. So at a certain speed, the upthrust force is bigger than the weight of the airplane, and will make the airplane start to fly. Okay. Same goes with the helicopter. You can see the rotor is an airfoil shape. So when the upthrust force is bigger than the weight of the helicopter will start to fly. Okay. And then this is another one, the last one, I guess, the Venti tube. So we could see, I will open it up. Okay. So you can see at this point the tube is wide, so the pressure is high. So when the tube is narrow, so the water flows faster, so the pressure is low. And then when we enter a wider tube, so the speed of the water decreases, so the pressure increases. Okay, that's all from me. Thank you.